Hello, today we're going to be looking at finding segment lengths. So for all of these, like you can see on the board there in front of you, we are starting out with some sort of diagram. Some things either given to you by being marked in the diagram or in words. And then our goal here is to be able to find the length of some sort of segment. So this goes back to our segment addition postulate. And I'm just going to kind of draw that out for us here real quick. So actually, you don't even need the congruent parts. Segment addition postulate said that if B is between A and C, then we can say that AB plus BC, their two lengths, add up to the length of AC, which is the whole thing. We're going to be using that a lot today, but on a kind of more advanced scale because we're going to be dealing with midpoints. If you looked in your notes, something that's very important here is the idea of a midpoint or a segment bisector. They are very similar to each other. Midpoint is if you have a specific point marked, like here I have point M, and when you see the two congruent signs on either side, that means M is the midpoint. So M is the midpoint of this line segment AB. This length right here from A to M is the same as this length right here from M to B. Or in other words, line segment AM is congruent to line segment AB. So sometimes you have a midpoint, which is just one point. Sometimes, like you see here and here, you have what's called a segment bisector, which is something that could still be a point, but it could also be a line, a ray, a plane even, some other sort of geometric object that is splitting your line segment into two equal pieces. Remember, these little red tick marks mean that those two pieces are congruent or that those segments are the same length. So for these two questions, they're kind of a two-part question, which is what your homework will be like. This one is similar as well, but more like the second part of most of your homework questions. Let's dive right in. So in the figure, PM equals 1.8 millimeters. If they give me a length like that, I like to write it M. So PM goes from P to M. That means this point, or this piece right here from P to M is 1.8 millimeters. They want us to identify the segment bisector of PQ, so this whole part, and then find PQ. So start list the segment bisector. The segment bisector is whatever is splitting PQ into two different equal pieces. So you might say point M, but it's not just a point here. I have something that looks like a point on one side, an end point, and then pointing off to the side forever. Remember that we call that a ray. And so my segment bisector is not the point M, it's this ray, MT. And remember when we're talking about a ray, we put the ray symbol over top, which basically looks like a little baby ray. So my segment bisector is ray MT. That part's done. Now I need to find PQ. That's the other part of what they're asking. PQ is this whole length here. But going back to our segment addition postulate, and knowing that M is between P and Q, I can say that PM, this part, plus MQ equals PQ. And remember, without the symbols above, these all just mean those lengths. So, do I know the length of PM? Yes, I do. PM is 1.8 millimeters. They gave us that here in the beginning, and I also marked it down here. Do I know the length of MQ? Right now, it doesn't look like it. But remember, these red marks mean that these two pieces are congruent. So if this is 1.8 millimeters, this piece, the other part with a red mark, also means that this is 1.8 millimeters. So MQ is also 1.8 millimeters. And when I add those together, I'll get PQ. 1.8 plus 1.8 millimeters can be 3.6 millimeters. So PQ, its length, is 3.6 millimeters. Before I do anything else here, I just want to remind you, and you'll see this on your homework, and if you compare some of the problems you see here with the notes problems, sometimes the objective is to find the whole length of the whole piece. Sometimes the objective will be to find the length of one of the smaller parts. So just pay attention to what they're asking for. Are they asking for the whole thing, or are they asking for a smaller part? Let's try another one. So here, point M is the midpoint of AB. Cool, we can kind of see that from what they're giving us, but they're just reminding us. They want us to find the length of AB. So AB is this whole thing. We can kind of see that it will be this part plus this part by our segment addition postulate. But when they want us to find the length, they want us to find an actual number. Right now we have just x's. So we can't find the length right now, but we have a way to get to it. Since M is the midpoint of AB, that means that the length from A to M, or AM, is the same as the length from M to B. Another way of writing that would be that line segment AM is congruent to line segment MB. However, if we're using it in the equation form, we don't use these symbols, we don't use the congruent sign either. So, length of AM is the same as the length of MB. Do I know the length of AM? Kind of, I know it with an x in it. AM is 3x minus 4. And same deal for MB. MB is 2x plus 1. Now, if you didn't have a picture here, didn't have the words here, this looks like an Algebra 1 problem, or like some of the basic algebra stuff we did earlier this year. So I'm going to solve this equation. Remember, when we're solving equations, we want to get our x stuff on one side, number stuff on the other, so I'm going to start by subtracting 2x from both sides. You could have subtracted 3x as well. Remember, there's more than one route to get to the right answer for these. 3x minus 2x is 1x, which is just x. Minus 4 stays the same. Those cancel like we want to. And we have just 1 left over here. And then one more step to solve this. I need to undo minus 4 by adding 4. I get x equals 5. Normally, when we get x equals 5, or whatever variable equals number, we are done. However, did it ask us to find x? No. It wants us to find the length of AB. We can do that though. So, since M is the midpoint, kind of like we had back here, and by using your segment addition postulate, we know that the length of AM plus the length of MB is going to be the full length of AB. Okay? AM is 3x minus 4. MB is 2x plus 1. However, we can actually plug in some numbers for these x's now. Since x equals 5, I'm going to turn this x into a 5 and this x into a 5. So 3 parentheses 5 minus 4 plus 2 parentheses 5 plus 1 is going to give me my full length of AB. I would recommend from here, type in all of this, everything before the equal sign, at once into Desmos. And I've already done that work, but if you want, or if you could do this by hand, that would be fine too. When you do all of that, you are going to get 22 for your AB length. So to answer what they're asking for, the length of AB is 22. Remember that when we don't use the line segment symbol above, it means length of AB equals 22. Again, you could do this part by hand. You would have 15 when you multiply here, minus 4 is 11, plus 2 times 5 is 10, and then plus 1. If you do all that, you'll get 22 that way too. Up to you. Another thing before I go on here is they could have asked for just the length of AM or just the length of MB. You would do a similar process, except for you would just plug in 5 for x. You wouldn't have to worry about this adding here. So just pay attention if they want the whole thing or part of it. Let's do one last one. So this one is more like this one because there's 2 things they're asking us for. First thing, what is the segment bisector of RS? So RS is this line segment from beginning to end. What sort of thing is splitting that into 2 pieces? Might be tempting to say point M, but it's not just a point there, it's a whole line. So our segment bisector, how are we going to name this line? Remember, for lines, we can name them one of 2 ways. If we have 2 identified points on the line, we can name it sort of like a line segment with those 2 points, just with an arrow over top. Or if it has a one-letter name like we have here, we can name it that way. So since I only have 1 point on the line, I can't do this sort of notation. I'm just gonna say line N. So line N is what's chopping RS into 2 equal pieces. Now they want us to find RS. From here, it's a lot like we did back here. We know that since line N is bisecting this, the length from R to M is going to be equal to the length of M to S. So RM is going to equal MS. Let's fill in what we know from the picture. RM, this part is 4x plus 3. MS, the other part, is 6x minus 12. So then, just like we did back here, let's solve the equation. I'm going to start by getting my x's on the same side. I'm going to choose to subtract 4x from both sides. If you worked ahead and did that a little differently, that's okay. And then I'm going to undo minus 12 by adding 12. And then last but not least, I need to get x completely by itself, so I'm going to divide by 2. And you're going to get a decimal, and that's okay. 15 divided by 2 is 7.5. So x is 7.5. Okay? Sort of like we did back here. We know that actually, let's back up. What do they want us to find? Do they want us to find RM? Do they want us to find MS? Do they want us to find RS? They want us to find RS. So RS is going to be RM plus MS, because M is between R and S. RS we don't know. RM we know is 4x plus 3. MS we know is 6x minus 12. But we can do one more step here. Do we know what x is? Yes, we do. X is 7.5. So just like I did back here, now I can put 7.5 in here and here. So 4 times 7.5 plus 3 plus 6 parentheses 7.5 minus 12. And then you can do this by hand, but I would recommend using Desmos just because it's faster and it's a resource we have. Type all of that into Desmos or simplify it by hand. When you do all of that, you're going to get that the length of RS is 66. So now we know how to deal with finding segment lengths if we're given information. If we've been given that something's a midpoint or a segment bisector, it means we split it into 2 equal pieces. Sometimes we have to do some algebra or solving equations like we did earlier this year. I hope you have a fantastic day.